Hello and welcome to another Physical Sciences 3 lecture. In this lecture we're looking at identifying isotopes using mass spectrometry. A method called mass spectrometry allows scientists to determine the mass of particles. A mass spectrometer can be used to identify which isotopes are present in a sample, since isotopes have differing masses due to their different number of neutrons. Other uses of mass spectrometry include identifying compounds in a sample, for example, presence of steroids or drugs in an athlete's urine sample, and identifying which atoms are present in a sample, for example, determining the chemical makeup or empirical formula of a new drug. A mass spectrometer converts atoms and molecules into positive ions to determine their mass. A graph of mass/charge ratio versus relative abundance of the ions is produced. And standard practice is to scale the most abundant peak to 100% or 1. Generally, the positive ions produced have a charge of +1, so mass/charge is simply the mass scale. Do not worry if a lot of that went over your head, especially the last couple of paragraphs. We'll look at some examples so you know what you will need to do if you come across these problems. So, an example here is analysis of gaseous chlorine vaporized in a mass spectrometer shows that it consists of 75% Cl35 and 25% of Cl37 biomass. Sketch a mass spectrogram for the vaporized chlorine atoms. Okay, so let's, this is a percentage, so relevant abundance is a percentage. So let's put in here 100, and halfway between 100 and the bottom we put in 50, not 500. 50. And here we'll have 75, and here we'll have 25. Okay, and I'll just put that in to signify we're breaking up the graph there. And the 75% was for 35, so we have 35, and try to use a ruler, please. But I don't have a ruler handy on me, unfortunately. And then 37 here for 25. Okay, so that's all we need to do. We have two peaks, two lines signifying what the relative abundance of these chlorine atoms are in the gas. How many peaks would a mass spectrogram of vaporized chlorine molecules have, and why? So chlorine molecules are Cl2. So there's two Cl molecules. So if we had Cl molecule there, Cl molecule like that, whereas chlorine atoms are just one Cl like that, one chlorine atom. So one atom, two atoms. So that's in a molecule. So a molecule has two atoms. So that means that we can make it up of, we can either combine if we have, go back up, we have Cl35 and Cl37. So let's say we have two Cls here of 35. That has a mass of 70. Okay, if we combine a 35Cl with a 37Cl, this has a mass of 72. And if we have mass two 37Cls, we have a combined mass of 74. So that's because, so how many peaks would a mass spectrogram of vaporized chlorine molecules have, and why? There will be 3 peaks. Because we can have 3 combinations of 35Cl and 37Cl to form Cl2 molecules. And sorry, my handwriting is bad. Okay, so that's why. So that's mass spectrometry, and we'll look at why we want to know these things in the next lecture.